Hi, grade 12s. Today our focus is on tangents. Right at the beginning, when we spoke about calculus derivative, we spoke about the fact that we're interested in the gradient of tangents to curves, and that is differential calculus. So all the time you've been finding the derivative, let me remind you that you were actually finding the gradient of the tangent to a curve at any point. So you have a curve here, and here we have a tangent to the curve at that point x equal to a, then the gradient of that tangent is actually equal to the derivative of the function at that point. So let's look at an example. It says determine the gradient of the tangent to the graph f of x equal to x cubed minus 2x squared plus 3 at the point x equal to minus 1. So when we find the derivative of this function, that is the gradient of the curve anywhere. So let's find the derivative using our rules. So it's multiply by the exponent, and exponent 1 less is 3x squared, and 2 times minus 2 is 4, and subtract 1 from the exponent. Of course that's a constant, so the gradient of the constant is 0. So the derivative is 3x squared minus 4x. In other words, this is the gradient of the curve, of the tangent to the curve anywhere. Now we want to know what is the gradient of the tangent to the curve at x equal to minus 1. So the gradient is equal to f dash of minus 1. Substitute minus 1 into the gradient function. Minus 1 squared. 3 times minus 1 squared minus 4 times minus 1. If you work this out, you'll get 3 plus 4, which is 7. So the gradient of the tangent to the curve at x equal to minus 1 is 7. Now let's look at the equation of the tangent. Remember, the tangent is a straight line, so we can use this formula to determine the equation of a tangent. And what is m? M is your derivative at that particular point where we're finding the tangent. And your points, because you need a gradient and you need a point to determine the equation of any straight line, and the point would be your point of contact if that is given. And then of course if a is the point of contact where x is equal to a, then to find y is just f of a. Let's look at an example. And in this example, the x value of the point of contact is known. Another word for the point of contact, the point of tangency. Okay, determine the equation of the tangent to the graph f of x equal to x squared minus x at x equal to 3. So here we looking at a parabola, and we're saying what is the equation of the tangent at the point when x is equal to 3. So what do we need? We need a point. We've got the x value, but we need the corresponding y value. We need the coordinates of a point, so x is 3. And how do we find y? This is y. Substitute x equal to 3 in that, and we'll find f of 3 is equal to 3 squared minus 3, which gives you 6. So the point on this tangent is 3, 6. Now we need a gradient. The gradient of this line, which is a tangent, we're going to find the derivative of this function anywhere, and that will give me the gradient of the tangent anywhere. So the derivative of this is 2x minus 1. And our gradient at x equal to 3 is substitute 3 into the gradient function. So it's 2 times 3 is 6, minus 1 is 5. So we have a point, and we've got our gradient. Remember, we want to determine the equation of a tangent. The equation is the tangent is a straight line. So we need a straight line formula. And all we do is substitute. We've got our point, 3, 6. So y1 is 6. m is your gradient is 5 and x1 is 3. So 5 times x, 5x, 5 times minus 3 is minus 15. Add 6 to both sides, and so therefore the equation of my tangent to the curve at x equal to 3 is y equal to 5x minus 9. Now in this case there was the x value of the point of contact. Now let's look at an example where the point of contact is not given. So here we want to find the point of contact or the point of tangency. So let's look at this. Say the graph of f of x, which is equal to x minus 2x squared, has a tangent with a gradient of 9. Calculate the coordinates of the point of tangency. So what have they given us? They've given us the curve, and they tell us that the gradient of the tangent is 9. So there's the curve. The gradient anywhere is the derivative of this curve. So it's 1. The gradient of x, the exponent is 1, and subtract 1 from the exponent here. So it's just 1, and the derivative of this is 2 times minus 2 is 4, and 1 less exponent there. So that's the gradient of the curve anywhere. And they tell me the gradient of the tangent that I'm looking for is 9. So the gradient is equal to 9. So 1 minus 4x, that's the gradient anywhere. We're looking for the x value when it's equal to 9. Now we're going to solve for x. So here you've got 1 minus 4x is equal to 9. The gradient is equal to 9. So it's subtract 1 on both sides. So you get negative 4x equal to 8. Divide by negative 4. And therefore x is equal to negative 2. So that is the place on the curve where the gradient is equal to 9. We want the corresponding y value because we're looking for the coordinates of the point of tangency. So we've got the x equal to minus 2, and we want y value. This is y here, not this. This is the gradient. This is y. So substitute minus 2 in here. Put minus 2, subtract minus 2 squared there, times 2. And you get a value of negative 10. Negative 2, square that is 4, times minus 2 is minus 8. Negative 2 and minus 8 is negative 10. So therefore the point of tangency is minus 2 minus 10. So here's the drawing of the graph. Here's my function, f of x equal to x minus 2x squared. And here I have a tangent with a gradient of 9, and we found the point of tangency. The second part says determine the equation of a tangent. Now I have a point on that line, the tangent, and I have the gradient. So all we have to do, we've got everything now. We've got the gradient, because they tell me the gradient is 9, and I have a point which is minus 2 minus 10. So substitute into the formula for a straight line. So it's y minus y1, which is negative 10. The gradient is 9, and it's x minus 2x1 there. So you have y plus 10 on the left equal to 9 times, in the bracket you've got x plus 2, multiply, get 9x plus 18, subtract 10 on both sides, and my equation of my tangent is y equal to 9x plus 8. And here you can see there's my tangent to the curve at the point x equal to minus 2 and y is negative 10. And there's our line.